This is from page 2 of the study guide for benchmark number 2. Let's take a look at letter E, and this one deals with writing an equation to match the scenario. So let's see what it says. A rope is 180 feet, is cut into 3 pieces. Second piece is twice as long as the first. Third is 3 times as long as the first. Notice what they compare it to each time. Here, let's underline what we've got here. The second piece is twice as long as the first. The third is 3 times longer than the first. They're comparing to the first each time. So we're going to call our first piece X. So let's go ahead and draw a little picture about what's going on. We've got our 180-foot rope right here, and we're dividing it into 3 different pieces. We cut it into 3 pieces. We got the first piece, the second piece, and the third piece. So what we're going to do is we're going to call the first piece X because that's what they're comparing it to each time. Notice how they compared it to the first piece. Compared the second to the first and the third to the first. So that's why our variable goes there. Second piece is twice as long. Twice means 2 times, so that's going to be 2x. The third piece is 3 times, so that's going to be 3x. The total was 180 feet, so we're ready to set up our equation. We'll have x plus 2x plus 3x. Those are the lengths of each of those pieces. So we added them together, and they equal the length prior to it being cut, 180 feet. And so that from that point, we'll collect some like terms. We got 1x, 2x, and 3x makes 6x equals 180. And so from that point, we just need to divide by the 6, and we've got our answer. So x equals, in this case, 30. So once we have that, doesn't necessarily mean that's the answer. Let's go back to the question. What is the length of the longest piece? Well, the longest piece is the third piece right here. And so what we need to do is we need to take x, which is 30, and plug that in to the x right there. So what we really need to do is do 3 times by 30. 30 feet is actually the shortest piece. It was the first piece. The second piece is 2 times 30. The third piece is 3 times 30. So 90 feet. There it is. Second one here, Ed bought 3 boxes of oranges, 1 box of pears. He spent $24 in all. The cost of a box of pears was $3. Oh, they tell us that. So $3 for the pears. So again, he bought 3 boxes of oranges and 1 box of pears. We know that the pears cost $3. Find the cost of 1 box of oranges. So let's set up our equation. We don't know the cost of an orange. Let's call the cost of an orange R. That's what we're going to say it is. So R, 3R, plus the 1 box of pears. So and means plus right here. That's why I put the plus sign. 1 box of pears was $3, it says, and the total cost was $24. Well, from there it's just a opposite operation problem. Subtract the 3, and when we do that, we're left with a 3R equals 21. So from that point, it's just a matter of dividing by 3, and we get our answer. So here it is. R is 7. So $7 is the cost of a box of oranges. Ted bought 5 bottles of water with a $10 bill. All right, so he bought 5 bottles of water with a $10 bill. We know that. Don't know how much the water cost per bottle. That might be what they ask for. Afterwards, he had less than $1 left over. So after he spent the money on the bottles of water that he paid with the $10 bill, so we're subtracting $5, or 5 times the cost of the bottles, and he had less. So this amount, he had less than $1 left over. And so this amount here, B, was less than $1. Well, the value, once we subtract this negative 5B from the $10 bill, we have less than $1. Write an inequality. Oh, we just did that. Write an inequality. Find the possible cost of $1 for the water. And so what we end up having to do here is doing some opposite operations. So we go ahead and subtract the 10 from all sides. And once we do that, still this negative 5b is less than negative 9. So from that point, we go ahead and do some division. And dividing by 5 does a couple things for us. It gets b by itself, it switches the inequality sign, and we end up with negative 5 going into 9. We have it one time with 4 left over. So what that is, oops, not 4/5, or not 4/8, but 4/5. So let's fix that. And so if I wanted to write this as a dollar amount, 4/5 is 0.8. So this is the same thing as b is greater than $1.80. So what that means is that if it were $1.80 for each of those bottles of water, it would be exactly $1. But he had less than $1. Because he had less than $1 left over, that means that the values of the bottle of water had to cost more than $1.80. Well, let's take a look at another one here. Questions 27, 28 are finding x and y intercepts. So remember, to find the x-intercept, you're going to end up setting y equal to 0. And so when you do that, you're going to cover up the y term, and all you got left is 3x equals 12. So you solve, and divide by 3, x is 4. So there's your x-intercept. Y-intercept, remember, you're going to do the exact opposite. You're going to end up setting x equal to 0. So that'll cancel out your x term, but remember, you got that negative sign in front of the y. And so you've got to divide by not only the 4, but the negative 4, and that gives you that negative 3. So you might end up seeing the answer as just a number like this, x equals 4. You could also see it as an ordered pair. That would be 4, 0 for the x-intercept, and 0, negative 3 for the y-intercept. So careful on that. X-intercept, again, all you're doing is you're setting y equal to 0. This cancels out. So you're left with that 1/2 x equals 2. Well, here multiply by the reciprocal. So I give you a couple problems to practice like this. So we're multiplying by 2. We're not dividing by 2, we're multiplying by 2. So when you do that, you've got x equals 4. So there's our x-intercept. Y-intercept, remember, don't forget about that minus sign. Again, you're setting x equal to 0. Divide by that negative 2. Y is negative 1. So there it is. Well, taking a look at this next one, same sort of thing. 1/3 x equals 8. So remember, you don't divide here. You multiply by that reciprocal. When you have that fraction as a coefficient, multiply by 3, or 3 over 1, and you'll get your x-intercept. And that is going to be a big number, 24. Wouldn't want to have to graph that. Go 24 spaces to the right there. And here for the y-intercept, it's just 4y equals 8. Divide by 4, and you got your answer. Y is 2. So there it is. Last one here to that type. 2x equals 8. Divide by 2, x is going to end up being 4. Over here, negative y equals 8. Divide by the negative 8, y is negative 1. So those are the answers. Again, remember they could end up giving you a problem or an answer as an ordered pair. And so if they do that to you, remember y at negative 1 would be 0, negative 1. And for x, that would be a 4, 0. And that could go with any of those. Well, over here, we're going to graph linear equations and inequalities. So the way they ask you these is they either give you a graph and you got to match the equation, or vice versa. They give you an equation, you got to match the graph. This is a great one for x, y intercepts. See, it's set up for that. So find the x and y intercepts. Here I have 5x equals 15, so x is 3. That's my x-intercept. So go over 3 spaces, put a dot. Y-intercept, negative 3y equals 15. Divide by negative 3, y is negative 5. So go down 5, 1, 2, 3, 4, 5. Put the dot and draw the line. That's it. That's all you're doing. And so, if it is in this form, x-y intercepts works really good. Look for the x-intercept, look for the y-intercept. Another problem. Here we have 2y equals 12. Actually, a negative 12 it looks like, so y is negative 6. So go down 6 spaces, 1, 2, 3, 4, 5, 6, all the way down the bottom. And for the other one, it's 3x equals negative 12, so x is negative 4. So go to the left, 1, 2, 3, 4. So again, just if it's in this form, XY intercepts is a great way to check to see what that graph is going to end up looking like. It's really fast. Well, that's what we're doing on this next one here. Going to solve for x, and remember you're using the reciprocal to get x by itself in this case. So let's multiply by 2, and see, you can see it really clearly here. 2 over 1, the 2's end up canceling out, but you got to do the same thing to the other side. So when you do that, you're left with an x equals 4. So over to the right, 1, 2, 3, 4, put the dot. So use this method again when x and y are on the same side. It works really well. Last one there, 2y equals 2. Divide by 2, y is 1. So you're just going up one space and drawing a line between those. And so far they're all equations in this case, but you could have some inequalities. So I'll get to those later on. Well, last one here of this type, you got 2y minus 4x equals 8. So 2y equals 8, and y would end up being 4. So you just go up 4, 1, 2, 3, 4, put the dot. Then negative 4x equals 8. Divide by negative 4, x is negative 2. So you go to the left, 2 spaces, put the dot, draw the line. Well, those are some of the problems you'll see. We'll finish up page 2 in the next part.